All right, so first we're going to do some inequality, or just one inequality. And two things to remember. Number one, compare to 0. So what I mean by that is you want to get everything on one side so that you're trying to figure out whether it's bigger than or less than 0. And then the second thing is the possible switching places are when the quantity equals 0 or is undefined. We talked about this a little bit last week as well. So let's say you've got -1 over x plus 5, and you're trying to figure out when that is less than or equal to -2. All right, so you're supposed to compare to 0. So first we're going to move the -2 over. So we'll just add 2. Of course, we're solving this. So that's what I mean by this first step. Compare to 0 means move everything to one side so that you're comparing to 0. And then I would probably get a common denominator at this point. So multiply the top and the bottom of the 2 by x plus 5. So all I did from here to here is I needed this to have an x plus 5 on the bottom. So I multiplied by x plus 5 on the top and the bottom. And that's legal because that equals 1. If you multiply by 1, you're not changing the value. So now I have a common denominator, I can just add them together. So it's -1 plus, I'll go ahead and distribute that at the same time, 2x plus 10 over x plus 5. That's less than or equal to 0. And of course then the -1 and the 10 combine to be 9. So it's 2x plus 9 over x plus 5 less than or equal to 0. Bless you. Okay, so then the second step is you need to find out all the possible switching places. So to figure out the possible switching places, that's when the quantity equals 0 or when it's undefined. So we're talking about this quantity right here. We need to see when this equals 0 and when that is undefined. So off to the side, we'll set that equal to 0. And also we'll set this equal to undefined. Okay, so the reason we're doing this is we're trying to figure out when the quantity is less than 0. And so that means that's when it's below the x-axis. So in order to figure out when it's below the x-axis, we can figure out where it might switch from above to below. And it might switch from above to below when it crosses the x-axis. So in other words, when it equals 0. or when it jumps over the x-axis, and that would be when it's undefined. So we're trying to figure out when it's actually below, but the way we do that is we find out where it might switch. Okay, so when is a fraction equal to 0? When the top is 0, right? So to figure this out, you just set 2x plus 9 equal to 0. And then you subtract the 9 over and divide by 2. So that comes out to negative 4.5. So that's one possible switching place. Okay, and then on the other hand, when is a fraction undefined? It's when the bottom equals 0, right? So we're going to set x plus 5 equal to 0 here, and that happens at negative 5. Yes?
What do you mean by switching point?
So we're trying to figure out when this is less than 0. And so we're trying to figure out when it switches from positive to negative or from negative to positive. That's what I mean by switching place. And that might happen when it equals 0 or when it's undefined. So that's why we're doing this first. Good. Okay, so now that we have all our possible switching places, we're going to mark those on a number line. So negative 4.5 is here, and negative 5 is there. And then we just have to test one point in each of these areas to see where it's below 0 and when it's above 0. So for this area that's above, oops, I messed up, didn't I? I got the smaller numbers on the left. Sorry about that. Okay, so for this area up here, I need a number that's above negative 4.5. So one number that's above negative 4.5 is 0. So I'm just going to test 0. So let's see, 2 times 0 plus 9 all over 0 plus 5. And remember, this is the important part. You have to show your work on this part. It's good to have the number line down on your paper because it helps organize your thoughts, but it isn't enough to show your work. You have to show that what number you plugged in, etc. Okay, so that comes out to 9/5, which is not smaller than 0, right? So that means that these numbers that are above negative 4.5 are out. And then remember, the great thing is, we only tried one number, but it works for all of the numbers up there. Because there's no switching place up there. So once we figured out that it was not going to work for 0, we know it's not going to work for anything that's above negative 4.5. So it's saving us a lot of time. We're finding out about all of these numbers all at once. All right, so in between here, I guess I'll do negative 4.8. So I'll take 2 times negative 4.8 plus 9 all over negative 4.8 plus 5. And once you show the specific work there, then you can start being a little more non-specific. If I take 2 times negative 4.8, that's going to be bigger than negative 9. Well, it's going to be a bigger negative than negative 9. So this top is going to come out to a negative number. And then the bottom comes out to a positive number. And if you have a negative divided by a positive, that comes out to negative. Which means that it is going to be less than 0. So that means all of these numbers in between negative 5 and negative 4.5 work. Okay, then I'm going to try negative 6 as my representative down there. So 2 times negative 6 plus 9 all over negative 6 plus 5. So that's negative 3 over negative 1, which is positive 3. Which isn't less than 0. So that means all the numbers below negative 4, negative 5 are out. Okay, now let's talk about negative 5. What happens when you plug negative 5 into here? You get does not exist, right? Or undefined. Is that less than 0? No, it's not. So that means negative 5 is not an answer. So to emphasize that, I'm going to put an open circle. Okay, how about negative 4.5? Let's see, that makes the top 0. And then 0 divided by a half is 0. So does 0 work here? Yes, because of that line there, right? It says it's either less than or equal to. With negative 4.5, it comes out equal to 0. So that means negative 4.5 is an answer. So to emphasize that, I'm going to fill in the circle at negative 4.5. Okay, so the numbers that work are negative 4.5, and then the numbers in between negative 5 and negative 4.5. So the final answer is all the x's in this interval, negative 5 to negative 4.5. And there's a parenthesis on negative 5, just emphasizing that that one doesn't work. And there's a bracket on negative 4.5, emphasizing that that one does. Okay, so that's solving inequalities. We had one other example last week on solving inequalities. It's not calculus, but it comes up a lot in this chapter. So that's why I'm making sure everybody knows how to solve those. Okay, we're also going to go and do some 4.2b.